According to National Electrical Code, Section 250.30 and Section 250.32b, the grounding and neutral conductors should be bonded only at the service panel. This is the first panel in your system, which serves as the main electrical distribution point for your property. Therefore, the ground and neutral conductors should only be bonded at the first panel. The ground rod at the second panel and the grounding system at the third panel are supplementary grounding systems that should not be connected to the neutral conductor. Let's summarize the bonding requirements. For the first panel, you should bond the ground and neutral conductors at the service panel. For the second panel, do not bond the ground and neutral conductors. The ground rod provides a supplemental grounding system. For the third panel, do not bond the ground and neutral conductors. The grounding system connected to this panel provides a supplemental grounding system. For the dryer circuit in the mobile home should be grounded and connected to the neutral conductor at the first panel. It should not be connected to the wiring of the mobile home that is fed from the second panel. To elaborate, the purpose of grounding and bonding is to provide a safe path for fault current to return to the source, allowing the overcurrent protection device such as a circuit breaker to trip and clear the fault. This is essential for preventing electrical shock hazards and minimizing the risk of fire. Bonding connects non-current carrying metal parts of the electrical system, such as enclosures and equipment grounding conductors, to create a low impedance path for fault current. Grounding connects the electrical system to the earth, providing a reference point for voltage and helping to stabilize the system voltage. The National Electrical Code, often referred to as the NEC, sets the standards for safe electrical installations. Adhering to the NEC requirements for grounding and bonding is crucial for ensuring the safety and reliability of the electrical system. Failure to comply with these requirements can lead to dangerous conditions and potential hazard. When dealing with multiple panels, it's important to understand the difference between a service panel and a subpanel. The service panel is the main panel that receives power directly from the utility company. It is the point where the grounding and neutral conductors should be bonded together. Subpanels, on the other hand, are fed from the service panel and should not have the neutral and ground conductors bonded. Bonding the neutral and ground conductors at multiple locations can create a ground loop, which can cause unwanted current flow and potentially create a shock hazard. In the case of a system with multiple buildings, such as the scenario described with the mobile home, separate buildings, and a dryer circuit, it's essential to follow the NEC guidelines for grounding and bonding each structure. Each building should have its own grounding electrode system, typically consisting of ground rods, and the grounding electrode system should be connected to the building's grounding system. However, the neutral conductor should only be bonded to the ground at the service panel, which is the main panel that supplies power to all the buildings. The dryer circuit, even though it's located in the mobile home, should be treated as a separate circuit and grounded back to the service panel. It should not be connected to the grounding system of the mobile home that is fed from a separate panel. It's important to use the correct size grounding and bonding conductors as specified in the NEC. The size of the conductors depends on the size of the service entrance conductors and the rating of the overcurrent protection devices. Using undersized conductors can compromise the effectiveness of the grounding and bonding system and increase the risk of electrical hazards. When installing ground rods, they should be driven into the earth to a depth that provides good contact with the soil. The NEC specifies the minimum depth and spacing requirements for ground rods. It's also important to ensure that the ground rods are properly connected to the grounding system using approved connectors and methods. Direct burial cables and cables installed in polyvinyl chloride, often called PVC, conduit should be installed according to the NEC requirements. Direct burial cables should be buried at the correct depth to protect them from damage, and PVC conduit should be installed in a manner that prevents moisture from entering the conduit and damaging the conductors. When working with electrical systems, it's always important to follow safe work practices. This includes energizing circuits before working on them, using appropriate personal protective equipment such as gloves and safety glasses, and verifying the circuits are de-energized using a voltage tester. It's also important to be aware of the potential hazards associated with working with electricity, such as electric shock, arc flash, and electrocution. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the work. Attempting to perform electrical work without the proper training and experience can be dangerous and potentially life-threatening. Furthermore, local codes and regulations may vary, so it's essential to check with the local authorities to ensure that the electrical installation complies with all applicable requirements. The NEC is a comprehensive document, and it's constantly updated to reflect the latest advancements in electrical technology and safety practices. It's important to stay up to date with the latest edition of the NEC to ensure that electrical installations are safe and compliant. In summary, grounding and bonding are essential aspects of electrical safety. By following the NEC guidelines and using proper techniques, it's possible to create a safe and reliable electrical system. Remember to bond the neutral and ground conductors only at the service panel, use the correct size grounding and bonding conductors, and follow safe work practices when working with electricity. If you're unsure about any aspect of grounding and bonding, consult with a qualified electrician. They can provide expert advice and ensure that the electrical installation is done correctly and safely. Understanding grounding electrode conductor sizing involves several factors. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. NEC Table of 250.66 provides guidance on the appropriate size of the grounding electrode conductor based on the size of the service entrance conductors. For example, if the service entrance conductors are 2/0 American wire gauge, often called AWG copper, the grounding electrode conductor should be at least number 4 AWG copper. It's important to consult the NEC table to determine the correct size for the specific installation. The grounding electrode conductor connects the service equipment to the grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a connection to the earth, which helps to stabilize the system voltage and provides a path for fault current to return to the source. When installing a ground rod, it should be driven into the earth to a depth of at least 8 feet, as specified in NEC 250.53 G. The ground rod should be made of a material that is suitable for direct burial, such as copper or copper-clad steel. The ground rod should be connected to the grounding electrode conductor using an approved connector. Metal water pipes can also be used as grounding electrodes, provided they meet certain requirements specified in NEC 250.52 A. The water pipe must be in direct contact with the earth for at least 10 feet, and it must be electrically continuous. The water pipe should be connected to the grounding electrode conductor within 5 feet of the point where it enters the building. If a metal water pipe is used as a grounding electrode, it's also necessary to bond the water pipe to the building's grounding system at another point to ensure that the water pipe is effectively grounded. Concrete encased electrodes, often referred to as UFA grounds, can also be used as grounding electrodes. A concrete encased electrode consists of at least 20 feet of bare copper conductor that is encased in concrete. The concrete must be in direct contact with the earth. Concrete encased electrodes are often used in new construction, as they can be easily installed during the foundation pouring process. The location of the grounding electrode is important for ensuring its effectiveness. The grounding electrode should be located as close as practicable to the service equipment. This minimizes the length of the grounding electrode conductor and reduces the impedance of the grounding path. The grounding electrode should also be located in an area where the soil is consistently moist, as this improves the conductivity of the grounding path. The grounding electrode system should be inspected periodically to ensure that it is in good condition. Ground rods should be checked for corrosion, and connectors should be checked for tightness. If any problems are found, they should be corrected promptly to maintain the effectiveness of the grounding system. Ground fault circuit interrupters, often called GFCIs, are an important safety device that can help to prevent electric shock. GFCIs are designed to detect small amounts of current leakage and to trip the circuit if a ground fault is detected. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. When installing GFCIs, it's important to follow the manufacturer's instructions carefully. GFCIs should be tested monthly to ensure that they are working properly. Arc fault circuit interrupters, often called clarifies, are another important safety device that can help to prevent fires. Clarifies are designed to detect arc faults, which are a common cause of electrical fires. Clarifies are required in many locations, such as bedrooms and living rooms. When installing clarifies, it's important to follow the manufacturer's instructions carefully. Clarifies should be tested monthly to ensure that they are working properly. Surge protective devices, often called SPD, can help to protect electrical equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, utility switching, and other events. SPD are installed at the service entrance and at branch circuits to protect sensitive electronic equipment. When installing SPD, it's important to follow the manufacturer's instructions carefully. SPD should be inspected periodically to ensure that they are working properly. Proper grounding and bonding are essential for ensuring the safety of electrical systems. By following the NEC guidelines and using proper techniques, it's possible to create a safe and reliable electrical system. Always remember to consult with a qualified electrician if you have any questions or concerns about electrical safety. They can provide expert advice and ensure that the electrical installation is done correctly and safely. The National Electrical Code addresses requirements for separately derived systems in Section 250.30. A separately derived system is an electrical system that is not directly connected to the utility source. Examples of separately derived systems include generators, transformers, and solar photovoltaic systems. When installing a separately derived system, it's important to follow the NEC requirements for grounding and bonding. The grounding electrode conductor for a separately derived system should be sized according to NEC Table 250.66, based on the size of the derived phase conductors. The grounding electrode conductor should be connected to a grounding electrode, such as a ground rod or a metal water pipe. The neutral conductor of a separately derived system should be bonded to the grounding electrode at the source of the separately derived system. This ensures that the neutral conductor is properly grounded and that a low impedance path is provided for fault current to return to the source. The equipment grounding conductors for a separately derived system should be connected to the grounding bus at the source of the separately derived system. This ensures that all non-current carrying metal parts of the electrical system are properly grounded. When connecting multiple separately derived systems, it's important to coordinate the grounding and bonding systems to prevent ground loops and other potential problems. Ground loops can occur when there are multiple paths for current to flow to ground, which can cause unwanted current flow and potentially create a shock hazard. To prevent ground loops, it's important to ensure that there is only one point where the neutral conductor is bonded to ground. This is typically at the service entrance or at the source of a separately derived system. The NEC also addresses requirements for grounding and bonding in healthcare facilities in Article 517. Healthcare facilities have unique electrical requirements due to the sensitive nature of the equipment used and the potential for electrical shock hazards. In healthcare facilities, it's important to provide a reliable grounding system to minimize the risk of electrical shock. The grounding system should be designed to provide a low impedance path for fault current to return to the source, allowing the overcurrent protection devices to trip and clear the fault. The NEC requires that all patient care areas in healthcare facilities be provided with a redundant grounding system. This means that there are two separate grounding paths for each piece of electrical equipment. The redundant grounding system helps to ensure that there is always a reliable grounding path, even if one of the grounding paths fails. The NEC also requires that all metal raceways and enclosures in healthcare facilities be bonded together to create a low impedance grounding path. This helps to minimize the risk of voltage differences between different parts of the electrical system, which can create a shock hazard. Isolated power systems are often used in operating rooms and other critical care areas in healthcare facilities. An isolated power system is designed to prevent electrical shock hazards by isolating the electrical system from ground. In an isolated power system, the electrical system is not directly connected to ground. Instead, a line isolation monitor is used to continuously monitor the impedance between the electrical system and ground. If the impedance drops below a certain level, the line isolation monitor will alarm, indicating that there is a potential ground fault. The NEC also addresses requirements for grounding and bonding in industrial facilities in Article 670. Industrial facilities often have large electrical loads and complex electrical systems. It's important to provide a reliable grounding system in industrial facilities to minimize the risk of electrical shock and fire. The grounding system in an industrial facility should be designed to provide a low impedance path for fault current to return to the source. The NEC requires that all metal raceways and enclosures in industrial facilities be bonded together to create a low impedance grounding path. This helps to minimize the risk of voltage differences between different parts of the electrical system. The NEC also addresses requirements for grounding and bonding in hazardous locations in Articles 500 through 516. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. In hazardous locations, it's important to provide a grounding system that is designed to minimize the risk of ignition. The NEC requires that all electrical equipment in hazardous locations be approved for use in those locations. The equipment must be designed to prevent sparks or other sources of ignition from coming into contact with flammable substances. The NEC also requires that all metal raceways and enclosures in hazardous locations be bonded together to create a low impedance grounding path. This helps to minimize the risk of static electricity buildup, which can be a source of ignition. In addition to the NEC requirements, it's important to follow any applicable local codes and regulations when designing and installing electrical systems. Local codes and regulations may have additional requirements for grounding and bonding that are not covered in the NEC. It's also important to consult with a qualified electrical engineer or electrician when designing and installing complex electrical systems. They can provide expert advice and ensure that the system is designed and installed in accordance with all applicable codes and regulations.